Hey guys, today we're going to take a look at confidence intervals with an introduction to the margin of error. A Gallup poll of 2,000 voters asked the question, do you enjoy learning math online? Find the margin of error for a 90%, 95%, and 99% confidence interval. In practice, pollsters often use a population proportion of p equals 0.5 to report the worst case margin of error. The margin of error is the critical value multiplied by the standard deviation of the statistic. We use z star to represent the critical value. First, we'll start with the 90% confidence interval. From the notes on slide 17, we see that if we want to create a 90% confidence interval, the z star value is 1.645. Next, we need to calculate the standard deviation of the statistic. So again, we're using 0.5 to represent the population proportion. So the standard deviation is the square root of the probability of success times the probability of failure, both are 0.5, divided by the sample size, which is 2,000. And using my calculator, that is approximately 0.011. So now I have both the critical value and the standard deviation. So the margin of error, which I'm going to use MOE to abbreviate, the margin of error for 90% confidence is the critical value, 1.645, multiplied by the standard deviation, 0.011. And I end up getting a margin of error of approximately 0.018. So that is my margin of error for a 90% confidence interval. Now let's transition to the 95% confidence interval, which means that we are more confident that we are capturing the true proportion. The z star for 95% is going to be 1.96. And again, that comes directly from the notes on slide 17. So we know that the margin of error, again, is going to be equal to the critical value times the standard deviation. The critical value has changed. It's now 1.96. But the standard deviation is the same, so you can use the same standard deviation for all of these problems. And we end up getting a margin of error of 0.0216. Again, it's a little bit bigger than the first margin of error, which makes sense because we are more confident that we're capturing that true proportion. For 99%, we can figure out that our z star is 2.576, so I'm just going to jot that down. We're working at 99% confidence here. So this is going to end up giving us the widest margin of error, or the largest margin of error, because we really want to make sure that we're capturing that true proportion. So the margin of error in this case, we're going to use 2.576 as our z star. That's our critical value. And we're going to multiply that by the same standard deviation that we've been working with this whole time. And because we're so confident that we've captured the true population proportion, we have the largest margin of error so far. It's 0.028. So you can see how the margin of error increases as the confidence level increases. I always think about it in terms of weather. Is it more useful to say that you're 50% confident that the high temperature tomorrow is going to be between 60 degrees and 65 degrees? That's a really small margin of error, right? Between 60 degrees and 65 degrees, but I'm only 50% confident. On the other extreme, I could say that I'm 99% confident that the high temperature tomorrow is going to be between 20 degrees and 120 degrees. I'm really sure, I'm 99% confident that I've just captured the true high temperature, but because my margin of error is so large, between 20 degrees and 120 degrees, it just doesn't serve any purpose. So with these types of problems, you always want to be confident, but you don't want your margin of error to be so large that the information isn't useful. So we'll be playing around with these numbers as we proceed with the unit.